I want to thank our sponsor, Planet Ford. Planet Ford has always been a proud supporter of law enforcement in the community, providing customer service and fleet management, sales, and service. If you're looking for that personal quality service, contact Planet Ford in Spring or online at planetford.com. You're listening to Crime Scene Today. I'm your host, Dan Zentek, where we talk about current and future issues facing crime scene forensics and law enforcement investigations. Today, I have Eugene Liscio, who is from Canada and deals specifically in research in 3D forensics. And so he's done some amazing research on those topics and continues to do some amazing things with that. And to look at his products and all, we have a lot of questions. There's a lot of people that after looking at his stuff want to know, how do you do that? What equipment do I need? What benefit is this in crime scene? So we just had an opportunity to reach out. He presented at Acer. If you didn't get a chance to go to Acer this year, the Association of Crime Scene Reconstructionists, please look that up. Look online, and there's just some great people there and just some great things that they're doing for our field in forensics. And so we look forward to next year's conference and what happens along the way. So, Eugene, thank you so much for coming in today.
Well, thank you for the invitation. I appreciate it. Thank you.
So I'll tell you one thing I want to sort of jump in and start with. I looked at your LinkedIn page, and you had posted a couple of different 3D images that we're zooming in. And I'm not sure if you're using drone, if you're using a different video process, if you're using Leica, Faro, those type of scan things. But so one was a building, and then it zoomed into what I guess to me would be a penny on the ground and had clarity all the way through during it. So I guess explain what that is, what's the process, what are we looking at there?
Yeah, the most recent ones that I had posted, those were both photogrammetry projects. So I'm actually using just software and then photographs. So there were two purposes for each of those. And it really came about from people who were asking a lot of questions regarding, can you, for example, mix cameras when you're using photogrammetry? And so for those of you that don't know, photogrammetry is where you take, a lot of photos and then you put these photos into a software package and then it spits out a 3D model. So kind of on a very quick way. So what I wanted to do was show people that you can, in fact, mix cameras. So the project of the building that you mentioned that kind of zooms out, that was just using a Nikon digital camera. I had two different lenses on there. One is a zooming lens, so I had two different settings there. I had a point and shoot camera, I had an iPhone, and I had a Samsung phone. And so I took all of these images, threw them in, and I wanted to show people that one big benefit of photogrammetry is that it doesn't have a fixed scale like if you have a laser scanner, a manufacturer will tell you that it's good down to, an eighth of an inch or something like that. And so what I did was I combined all this stuff and I put it was a 1 penny, it was a 1 cent euro that I threw on the ground. And then I zoomed out from far and showed how you can come in from a very wide sort of shot far away and how you can come in very close to get a lot of detail if you want. And that's one of the advantages of using photogrammetry. And it's all in one project and processed all together in one shot, which was great.
Now you said you used numerous cameras, and you talked about some of them. So how many photos are we talking about? I mean, from like beginning to end, what are we looking at?
I think that might have had about 100. I think if I remember correctly, it was like 150 photos, something like that. So it was about 20-ish from each camera. So it wasn't. I'll be honest with you. I was surprised at the reaction I got online. So I didn't think it was. I thought it was cool or whatever, so I just kind of put it on, but it actually got a lot more attention than I thought. So, it wasn't, if I had known, I would have actually gotten closer so I could really zoom in.
You would have done more.
Yeah, I would have done more. So,
Well, and I think the big question is that, so obviously 150 photos, it's not that you took a quick one camera, one shot, and all of a sudden had all this great detail from wide to zoom. There's a process, sort of like HDR photography is blending different lighting elements. This is obviously blending, different focal lengths and things of that nature. So, and you talked about dumping it in. So I know very little about the photogrammetry. I mean, I've dealt in the HDR stuff of using photomatics and HDR stuff.
Hmm.
So, what programs are you using in photogrammetry when you say dump this in?
Right. So in that particular instance, I used a program called 3DF Zephyr, and the company is called 3D Flow. So it's an Italian company, and they have a really great product. But I do use other photogrammetry software. So there's another one from a company called Agisoft, which the product is called Metashape. There's another one that I really like. I use a lot for my forensics work, which is called Photomodeler. And it's a very comprehensive photogrammetry package that does more than just sort of creating 3D models. Um, the the nice part about the 3DF Zephyr is that they have a free version. So if you just want to try it out or give it a shot, and that's what got me interested originally. They had you can load up to 50 photos and then process them and come up with a 3D model. And there's some restrictions. You don't have everything, but it was really great. You could do quite a bit with very, very little. So, most people have a camera or they have a phone and take some shots and then, process them through the 3DF Zephyr software. And you can be really impressed with what you can create. Yeah.
So obviously we broadcast all over the world, and there are departments that have plenty of money. I shouldn't say plenty. No one has enough to accomplish things, right? But then there are very small departments. So what type of financial investment to accomplish, I guess, the basic image to do that?
Well, if you are somewhat spirited, then there are actually free options. Okay, so if you want to get in and try some free stuff, there are other programs out there that will actually develop a point cloud. There's one called Visual SFM, Structure from Motion. There's another one called Meshroom. That's a popular one that a lot of people are working with right now. The 3DF Zephyr one is another one that I said allows for 50 photos free. But in terms of cost, some of the companies have sort of a graduated pricing. So if you just want to, so for example, 3DF Zephyr has their standard version is less than $200 US. I think it's maybe it's like 160 or 170 euros or something. So it's about $200, let's say. And that will allow you to process up to 500 photos, which for most projects is absolutely fine. It's plenty of photos. And it doesn't matter, like if you're flying a drone, if you are, just using your Nikon camera or Canon or phone, like whatever it is, including video. So often you can process video as well. I believe Metashape from Agisoft also has a version that's like a couple $100. And then if you really want every feature and you want to spend the big bucks, you can get up to several $1,000s. So we're talking about, let's just say you're somewhere in the $5,000 range, $4,000, $5,000 range for software, and aside from all the other maintenance and other things. So it's not that bad when you consider, the laser scanner. If you buy a full-fledged laser scanner, comparatively, the laser scanners can be quite expensive, right? They're great instruments. Don't get me wrong. They do incredible things, but of course, they're great tools because they also work together, right?
Right.
So that's the other thing. So you'll see often people online they'll do this thing where they want to pitch one against the other, and I always say that it's just for marketing purposes. They just want to say laser scanning versus photogrammetry,
Right.
but the truth is that they work very, very well together. And we can imagine a scenario. For example, you get to a crime scene and there's a body on the ground, and body may be the first thing to get out of there. So grab your camera, click, 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 click. In 30 seconds, you've got enough photos that you can create that body model again. And then afterwards, you come in with a laser scanner, you collect the data for the house or the apartment or whatever it might be. And you can always put the body back in place where it was before. So
And so, I mean, that brings the big question, right? And I mean, you've sort of touched on it, but to expound is the why, right? Why do this? I mean, obviously, we're talking about crime scenes, we're talking about forensics. So, what, we're always looking at new technologies and things that help us. So why 3D? Why the scanners? Why the photogrammetry? What benefit to the investigators, to the courts? Why are we doing all this?
yeah, that's a good point. So, with respect to a lot of the newer 3D technologies, often when people see the product, so they'll see the model or the scan, there's like a wow factor, like, oh
Sure,
wow,
it looks
that's
cool. Yeah.
yeah, yeah, looks cool, right? But I always say, cool doesn't sell, right? So cool is great, but if it's just cool to look at, well, that doesn't have a lot of utility always, right? So for me, I think there's a few things. So the first one is the speed of documentation. And so if you had a crime scene that was in an apartment and it's a wide open kitchen and there's nothing around, it's beautifully tiled floor, that's easy. So you can pull out your tape measure and you could probably accomplish, a quick sketch or a quick, scene diagram, whatever, without too much effort. But now let's take that scenario and let's shift it to a forested area on the side of a hill or something like that. Well, all of a sudden, hand mapping doesn't cut it anymore, and you run into all sorts of problems. So, inside of vehicles, for example, it becomes very problematic to try and document things properly. And of course, the digital camera is fantastic because you can take photos. But when you're talking about trying to get measurements, you can now leverage the digital camera for the photogrammetry. You can have a hand scanner, for example, where you scan by hand, the interior of a car or a body on the ground, and you can have the terrestrial laser scanner that would be great for large outdoor scenes, crashes, and all that sort of thing. So speed for sure. There's no, for example, with the laser scanner, there's no other instrument in the world that's going to document as fast and as much data. There's nothing else in existence.
Now, there's been a lot of advances on the laser scanners, but I remember in the beginning, when I say beginning, I think we had gotten a Leica 360 back in 2013. And one of the issues we had then, and I know it's improved, but one of the issues we had then was linking scenes together. Like you talked about the kitchen that's wide open, but what about the hallway we need to go down that the other body's in the bedroom, and linking those together? How, I guess, where are we at with that? How easy is that to do now?
There are there's just some basic principles that you're never going to get around from. And so, you can think of a scan as like a piece of a puzzle, right? And if you have one piece of the puzzle, that shape that it has to fit with another piece of the puzzle with a similar shape or similar geometry. So, you have to be able to link these together. You can't just kind of like, take one of the kitchen inside and then walk out to the street and do one there, and then all of a sudden go to the basement and take another one. That's not really what it's intended. So you could say one of the weak points of something like the laser scanner is that they have to be generally sequential. Like they like a very structured and organized manner in which you scan, and then it'll piece everything together, from top to bottom. But the algorithms that are used today are much improved over 10 years ago, let's say. So people were using targets before a lot more, and targets can sometimes still be used, and sometimes they're necessary, and that's just because of the geometry and the way that the algorithms work. They break down under certain situations. So very, very much improved, very robust. Sometimes I'm actually surprised. I'm just like, wow, this thing came together really, really, really well. And but they're certainly made so they make your life easier these days.
And I know that one of the, I guess, selling points, even in the beginning, was that so we're capturing the scene. That if there's something we didn't measure in the first place, we can go back and measure it later. I think something that we've seen that's been added that we didn't have back then and in recent years is drone technology,
Yeah.
right? And us putting the cameras on the drones. What's been your experience with that, and I guess the advantages of us being able to put that in our technology?
Right. Well, again, with the drone, so photogrammetry itself is not anything new. So when the first camera was made in the 1850s, it wasn't much after that. It was a few years after that where there was a Frenchman named Aimé Lossedat, and he said, "Hey, I think I can use this camera for surveying." So photogrammetry had very, very early roots, and so it's been developed. I got into photogrammetry in 2006, and so drones actually helped photogrammetry. It sort of gave it a real kick in the pants, because it wasn't that you couldn't do it before. It's just everybody has a drone and it's so easy to fly, and you can get the camera to a position which is super, fantastic. You get a great shot. So for outdoor scenes, the speed at which you can document a crash scene or a large section of roadway, of buildings or whatever, is just fantastic. I mean, in a 10-minute flight with a drone, it doesn't sound like a lot, 5 or 10 minutes, but you can document one heck of a lot of area in 10 minutes. So that is a huge plus for crime scene investigators and for people that are doing accident reconstruction.
Yeah, my understanding is that at least whether there's programs, maybe it's built into the drone, but there's certain programs that I guess you can set up where it obviously we all know they take video, but there's a way that it'll like take so many photos in a track or that
Right.
type of thing.
Right. So yeah, photogrammetry packages, like when you have a lot of overlap over the photo. So you fly the drone and then you kind of, get like 70, 80% overlap, and then kind of go from there. So there are programs, you can get little apps where you can say, you just drag a rectangle around a map, like a Google Maps type of thing. And you say, well, I want to photograph this whole area, and I want a certain amount of overlap between the photos. And it just goes and flies the mission for you, right? Which is pretty cool. And in fact, I thought it was Montgomery County that had a drone a long time ago, actually.
We
And
did. We were one of the first people to have a drone, and
I'm trying to remember his last name. Dale? Is it Dale? Oh, geez. I don't remember. I'm trying to remember his name, but there was a demonstration that I saw out there, and the first time I
no,
saw it,
let's see, probably Damon Hall.
Damon Hall. That's it.
Yes,
Sorry,
yeah,
Damon
Damon
Hall.
Hall. I think we should have waited, but and we got in, and it was one of the. I mean, don't get me wrong. I brag all the time that the Montgomery County Sheriff's Department certainly back then. If there was technology we needed to do our job, that sheriff at the time, which was Tommy Gage, would give us that technology. That's how we got our Leica 360 scanner in 2013, when I won't say they were coming out, but they were certainly way more expensive than they are now.
Oh
And we
yeah,
got that, and we got the drone. But the drone we got at that time looked like a helicopter. It didn't look like the quadcopters that we see now. It looked like a miniature helicopter, and to fly this required like a flight station out of the back of a Tahoe.
I remember that. I saw it. I
And
remember
so
it.
it's, like I said, I wanted to say early phases, and now you have drones that can do way more than that one could at 1/10 of the cost of what we were dealing with then. So
Yeah.
we still have drones as part of it, but yeah, we were early on that. That one died a horrible death by going into a lake, and
Okay.
so we recovered that and stuff. But anyway, that's a story for another time. But yes, we were early on with the drone, but we weren't. We were still experimenting with using the DSLR on the drone, and I want to say it was sort of experimental, just in the fact of different softwares and things that we were trying to
Right.
use and such. And I think that's come a long way. I've heard of one software. I've not used it, but I've heard it to where I nearly believe it's sort of a standard with some people. Was Pix4D.
Yep.
Okay,
Yeah.
so
So I don't use Pix4D, and it's only because Pix4D kind of came in a little bit later for me. So I was already using different software, but I would recommend Pix4D. So if you're flying a drone and you're going to be doing a lot of drone missions and stuff like that, like Pix4D they did a really great job of supporting that industry, the public safety industry, market or industry. And they've made it, they've placed a lot of integration with software and other apps and things like that. So yeah, Pix4D is definitely a big name. And They jumped on the drone bandwagon when it was early on, and they did really well for themselves.
So, I mean, and I understand your education level is higher than most, but how easy is this software to use for the average CSI, for the average person that's taking some photos? And I know you say just dump them in, but obviously there's probably a lot more than just dump them in, and we have this awesome thing.
So yeah, this is what I always tell. So I just finished a class. So the Tuesday and Wednesday, I taught another class, and so I had about maybe about 50% of the people there were like accident reconstruction, forensics type people. And by the time they're done, after once they get about 10, 12 hours, they are pumping out 3D models. So the issue becomes not so much can you create a model, it's whether you can create a good model, whether you can have it scaled properly, whether you can recover from something that isn't working for you. Like how do you go back and fix something afterwards, right? So it's all these other little things. Or there's a lot of advanced methods that you have to use, like if you want to integrate with laser scanner data, if you want to use ground control points. So it kind of escalates, but just the basics, being able to fly a drone, take the proper images, and knowing how to do that manually without a lot of input or a lot of automation is not that difficult. You can definitely do that with a very, very short course. Yeah, and a lot of the software that I'm talking to you about is fairly simple to use.
So now, as far as um, a lot of the things that we use the 3D for is for reconstruction, right?
Mhm.
And so, how does this work in inserting models on top of? So obviously, like using Poser or other type of model positioning to put into this and do your reconstruction.
Yeah, so once it's in a 3D format, having a program like 3D Studio Max, which I tend to use a lot, or regardless if you're using like something from Leica, like Map 360, or if you're using Ferrozone 3D, whatever it is, they'll be able to import all these models from different sources, which is really great. And so the fact that 3D models talk well together is super beneficial. So you can take a character model and you can rig it up to show trajectories, or you can take a vehicle and show trajectories on a vehicle, and then import the vehicle separately on the drone data, for example. So you can have the roadway and put a car back in with trajectories. So yeah, there's definitely a lot of opportunities for doing reconstruction work. And in fact, that's a lot of what we do. That's a lot of what I do. And we've done a lot of work on shooting cases. So especially officer involved shooting cases. So
Right.
that's a big deal recently. So that has been super helpful. And, you know, I'm finding today that there are a lot more agencies that already have the data. So before I had to bounce around and travel to, get my own data or go scan a scene or something like that. And nowadays it's like, hey, do you got the data? Oh yeah, we got some drone images, and we have a scanner or whatever. It's like cool. So it made my life easier, right? So we're getting fed a lot of that data today, which before we had to go and obtain ourselves. So that's a good sign. That's a really good sign that agencies are adopting these technologies.
So, what would you say is the most common question? Like, if I'm calling you, whether it's as an attorney or an agency, and obviously what you do is reconstruction, what's the most common question that I want answered?
There are different types of cases that we get. But I can tell you this, that almost every case that we do where we take the pieces of a number of different things and create a reconstruction in 3D, you almost always learn something that was maybe difficult to visualize or understand otherwise. And sometimes it just makes you think about things that weren't immediately apparent. And so kinds of things that people want, for example, it's like sometimes they'll call and say, hey, we want an animation. So they just call it an animation, right?
Right. Sort of a
They want,
walkthrough. We want you to show us what happened. Right.
well, when they say animation, I'm not sure if they know what they mean. So sometimes they mean they kind of want a camera fly through, kind of showing the scene. Sometimes it means they want people running around and doing all kinds of stuff like that. So um, I don't do a lot of the animated things where people start running around and that sort of thing anymore, because it doesn't. Uh, I just find it it becomes a little bit of a battle to get into court. It goes under a lot more scrutiny. So for years now, we've really been trying to focus more on the the accuracy, bullet trajectories, bloodstain patterns, the kinds of things where you can take this 3D data and then apply it to something. And that's really the area of interest for me. And that's where we've been doing a lot of research is, the documentation is one side, but then there's this whole other realm, which is now I've got the data. What kinds of analysis and what kinds of information can I extract from this data that can be super useful to the case? And so those are the kinds of things we work on.
So, what would you say that, and I know you've done a lot of research in different areas. So, is there something that while you're going, and I'm sure there is, that as you receive some data, as you're working a case, that it's brought just your curiosity to answer a question? Like, I never thought of this before. Can I figure this versus that? Or, what's some topic that sort of, by doing this, I wanted to learn more about something?
Yeah, and there's so many different things. Like, so for example, let me back up, because when I first got into this, I sort of saw the writing on the wall, and I thought, you know what? I don't want to be the first one on the stand going, yeah, I did this thing. And they're like,
Right.
and who's done this before?
Yeah.
And I'm
No
like,
one but
yeah,
me. I am it.
exactly. So I figured, well, maybe I'll be the first one, but I don't want, at least I want to have something published on it to show
Right.
that I've tested it and it's been peer reviewed and people have, criticized it or something, right? So that's where a lot of the research stuff started. And then through different cases that I've had, it's branched off into like different things, because you're like, damn. And that's where a lot of people like yourself or other people that are doing casework are like, damn, like this is something we've never seen before. Like, I wonder, like, has anybody tested it? And then they go in and they look in the literature and they're like, there's nothing here. Like, what I mean?
Right.
Like it's a wide open space. And, when I first started in this area, I thought, police have done it all. They know it all. They've been doing this for
That
years.
that's what we want people to believe. You keep going with that. That's working well.
Yeah, yeah, yeah. So, and then as I started getting deeper into it, I'm like, well, has anybody done this? And it's like, no. And you look around, it's like, well, there's very limited information. So I've done a lot of the research like that. To answer your question, there's a case that I had once that was like a bloodstain pattern case. It was a gunshot spatter and misting and stuff like that. And that really piqued my curiosity. So I teach at the University of Toronto in Mississauga. It's the city beside Toronto in the Forensic Science Program. So we get intern students regularly. So we had 4 this year. And one of them had a gunshot misting project. And so, we set up experiments. And it's not necessarily 3D, let's say, but, it's something where we're trying to look at what is the cause and the effect and variables and things like that that come into play. Another one had to do with cartridge case ejection patterns. So if you look in the literature, there's a few things on cartridge cases, but not a lot. Certainly not in the ejection patterns. And you'll be very hard pressed to find anything that looks at blind studies for cartridge case ejection patterns. So I had a student this year. We ran some tests. We did some cartridge case ejection patterns. We used photogrammetry. We used the laser scanner for the documentation, but the analysis was a different aspect. Forensic anthropology, an area that I'm not, a lot of the students that come through the university they sort of have an anthro, bio, chem background,
Right.
which
Right.
is not my background at all, right? So, but, I get involved. This year we had a project where a student was making cut marks on bone, and we were increasing the weight on the blade of the knife and using different types of blades to look at the type and depth of cut. And the way we documented those cuts on bone was using a 3D microscope from a company called Keyence. So yeah, everything you said, like, you get ideas from cases, you get ideas from all different places when it comes to research.
Now, I know most of the police training, or I should say crime scene training that we've talked about when it comes to ejected cases is, and just from working scenes, um, we have a decent distance, but we always sort of throw it out the window, right? Depending on what it hit, what it bounced off of,
Yeah.
where it could have ended up, So And I don't know your research on this, but I mean, was this different calibers? Were there items that it would have bounced off me? What were you finding was like the area that we're looking in, or what was your question and goal?
Right. So obviously we have to start someplace, and I know, and believe me, everybody and their brother was telling me, cartridge cases get kicked around and people step on them, and I'm like, I know, but I've had more than one case where I know, the cartridge cases fell in grass and they
Right.
didn't get kicked around. I had one where it was in snow, and I know that it didn't get kicked or launched around because there were no footprints in that area or anything. So there are situations and cases where it may be useful. So just to answer or to even get a sense of what kind of errors are we even talking about, our research focused on flat concrete floor, like very smooth floor. So these things have a lot of room to sort of move around and bounce around. And the assumption is that nobody, sort of affected it. So what
Right.
we did was we used for this particular study, we used the same caliber and same ammunition, and we had multiple people fire a gun in sort of a standard grip, double-handed grip shooting position, and from different heights too. So we'd have people
Okay.
kneel, we'd have people standing, and we had different heights of people. We had men, we had women. So ultimately, we have hundreds of these fired shots, and we document them all, and then we try to figure out, okay, what's the average direction and distance from the known shooter position, and that's the starting point.
Okay.
Yeah. So then what we want to do is say, okay, let's assume I have a crime scene now. I got 3 cartridge cases, and let's assume it's in the sand or dirt or somewhere where we didn't kick it or whatever. So we're fairly comfortable with the cartridge cases are in their final resting position. What we're doing is we're looking at 2 scenarios. One is you have no idea where the shooter was firing.
Okay.
So that's one scenario. Just you got 3 cartridge cases. Where was the shooter?
Somewhere.
Somewhere. So you end up with this sort of like these rings, like satellites kind of thing. The other one is where you know the direction of fire. So you know that maybe there was a victim standing, 20 feet away from the shooter or something like that.
You at least
So
have a bullet hole or something to work off of.
yeah. So now it is where along that path was that person standing. So we're looking at those types of scenarios, and we're learning a lot actually. So the other thing too is, for example, we recorded where the cartridge case first impacts and
Okay.
then the final rest position. So we're not just doing the final. We're like, where does it first hit, and then how far does it go? So we're finding. We found cartridge cases, as far as or more as 7 meters. It's like 20, more than 20 feet, right? So they can move. They can move,
That has been our
and
experience. Yes.
yeah, they definitely go. They can definitely go far in. And then on average, it's something on the order of about 12 feet. Now, here's the kicker: we've had everybody standing in the same position and everything else firing these guns, but the person firing, even if they're holding in the same position or whatever, and it's
Right.
something you'll see, you get the big guy with the big pipes, big arms,
Right.
and he's like,
Right.
yeah, let me fire this thing. When you have somebody that's very sort of holding the gun very rigidly, their cartridge cases go flying. I mean, they go. It's just, you can see it, like they just go flying way off. And then if you have somebody that's kind of noodle arms, kind of
Right.
thin guy,
That's
they fall right beside you. They just go bang bang. They fall right beside. So the shooter has a lot to do. Like just one variable can affect this kind of thing quite a bit. So it's a really interesting project, and we're continuing it on. I have another student this year, this summer, and I'm hoping that we'll be doing some more with different calibers, different people, and different things to see what we get.
that is interesting, and like I said, I know that it's something that we deal with, and many times it's. I mean, you're sitting there staring at one another, and it's like it's in this room. I mean, we know for a fact. There's not a 9 millimeter revolver out there. The casing didn't go with them. It's somewhere here.
Yeah.
And of course, I mean, and I completely understand the foundation and basic research that you're trying to find. But when you do enter the couch and the TV and the coffee table and it can bounce off this, it can go in this and
Oh
whatever,
yeah.
but certainly to have the answer of it can't be past this point,
Hmm.
right, is helpful.
Yes,
Uh,
absolutely. And the other thing that, I mean, part of the research was also to help establish a method of testing. So I've been talking to different people around the world actually that, will do ejection pattern testing. And what I found is that they don't do hundreds of shots. They do five, they'll do 10, they'll do six. Statistically, it's not a large sample size. And
right,
one of the reasons why they don't do that is because they got to measure every damn one. So they
right.
don't want to do 300 measurements. But so in our because I have a little bit of, photogrammetry or whatever, we actually just use the GoPro to
Okay.
record, just to record. So from video and from establishing a known grid on the ground, we can fire thousands of shots and we can just use the video and just pick off points in the video, and we're able to get measurements down to like a quarter inch kind of thing to the cartridge cases. So having a means or a method of documenting the cartridge cases during the test, which is much easier, may give people you know, forensic practitioners another tool, or may give them a little bit more incentive to test more shots or take more cartridge case measurements on the ground.
So where do you see? I mean, obviously, just in the time of our careers, the advancements that we've seen. What do you see next? What do you see being, whether it's just something we have that's enhanced or something that's coming up? What do you see as next beneficial to what you're doing that's not developed yet, but you see it coming?
Right here, right there. So that's the iPhone 12. And right at the very bottom here, one of these, there's a LiDAR sensor there. So that little dark
I
thing at
saw
the bottom.
something on that. Yeah.
Yeah. So very interesting. So it's something that I've been doing some testing on, and I've placed a couple of videos online looking at accuracy and how it might be able to be used. So the LiDAR that's built into this thing, it's incredible because it's now in a device that everybody typically has, right? So
Right.
that's
Right.
cool. And it's, I don't know what an iPhone costs now. It's, $1,000 or something, whatever it might be.
Yeah. Still expensive, but
It's
you know.
still expensive. Yeah, exactly.
But when you're
Um,
talking about, now we're talking personal individual, but when you're talking about a government entity versus buying a multi-million or multi-thousand-dollar laser scanner,
mhm.
versus an iPhone that many of them are issuing due to uh, things like evidence.com is just one that I think of, but where they're able to take video, take photos on a scene, upload that to their evidence repository. So that's a very likely tool that could be
Yeah,
issued
yeah.
in the field.
You
So,
know,
what are you finding on its accuracy?
this one here, it's a few centimeters. So, for example, I did a vehicle, and when I did the vehicle, I think I was on the order of like, let's say about 3 inches, something like that. So what happens is if you just use the raw data that comes out of it and
Right.
then measure it, then it's kind of horrible. It doesn't actually work all that great. But some companies, like there's a company that I'm testing their software or their app, and it's called EveryPoint. It's free, so anybody can try it. And what I'm finding is, this is what's really cool. You asked about what's coming in the future. It's sensor fusion. So, taking the LiDAR sensor and then taking photogrammetry, and they're combining it together. So, when photogrammetry fails, the LiDAR kind of kicks in. And when the LiDAR kind of fails, the photogrammetry kicks in. So or at least they help each other. They're working together. And so you can do things, and the quality of the data that they're getting is like really cool. So it's not quite there yet. I don't want to give people a false impression. The models look cool, like we talked about before, the
Right.
cool factor, but they need to implement a few more little things which can help people understand, especially in forensics. The most important thing that I always say to people is it's not the answer, it's the error. You have to understand the error, right?
Right.
So,
Well, it's like you
um,
said. I mean, it's a cool thing and it's coming, but you said you were getting what, 3 centimeters or three
oh,
inches,
inches.
or I
Yeah.
mean,
Yeah.
and
So,
when you're talking about that for scientific measurement, that's not going to work,
yeah, I
right?
mean, for accident reconstruction people, if they want to, take a quick scan of a car because they've got their phone with them or something, I mean, that's okay. I mean, I can see that, it might be all right. But would I hang my hat on a bully trajectory
Yeah.
analysis right
Yeah.
now. Probably not. You know what I mean? It's not ready yet, but maybe it'll move in that direction. Maybe, there are some things that they can implement. We're still at a very early stage. It's the first release of the LiDAR on the phone, and I'm sure, other companies are probably going to start getting competitive, or maybe they'll start releasing some smaller sensors that are more accurate. Who knows? We'll see what happens. But that's this sensor fusion thing I think we're going to see more of, and more mobile, a lot more mobile. People are really like thinking about, if I can walk around with this device and just kind of capture a crime scene, like just, you were talking about like putting the house together or whatever before.
Right.
So what if you could just walk through the house and something is just, tying it all together for you? That's kind of the holy grail of scanning, but again, not
Well,
quite there
and
yet.
I've seen that sort of, right. So I know at Acer, and I'll give them a free plug here. Was Faro was there, and they had their handheld that allowed you just that to walk around, walk through, had your positioning, and to blend those together. And I am curious I mean, obviously it's all proprietary. They're not going to share their information, but obviously reverse engineering and feeding off of others, of taking what we now see from Leica and Faro, and whether we start seeing it on mobile type devices,
Hmm.
putting, I think another was using GPS along
Yes.
with it, to
Yes.
try to, so you could, like I said, in the past you had the scanner and you had to have either targets or something that you had tied. Now it's just GPS point of, we know where this was and we know where you took it to, so now we're
Yeah.
going to tie those together.
Yeah, there's so aligning the scans together is a term that people will often hear. It's called registration. So it's a fancy word for aligning these two scans together. And so having points, so if I have a scan here and I have a scan here, and I'm like, well, these points are the same, these points are the same, these points are the same. I can take these two scans and say, oh, they fit like this, and all the points come together. But another way to do it, a lot of people know it as called cloud to cloud registration. So the point cloud is just the collection of all the points that the laser scanner collects. And so you take one cloud and you take the other cloud, and they get put together based on their similarity. So the overlapping geometry that's similar, it can kind of put the two together, and then it kind of massages them in and looks for the least amount of error. And when it finds that point where, they're both positioned really, really tight, it says, hey, I think they're registered together. And so you don't need targets when you have good geometry. That fails though when, for example, let's say we're in the middle of a sandy, wide open desert area. There's nothing around. All you have is just a flat, sandy ground. Well, if I scan, 500 feet that way, it looks exactly the same as
Right.
500 feet that way. So then it breaks down, and you definitely need targets. The other place that targets are really helpful are when you get a body that's in like a forest or something like that, because there's so much stuff around you that when you move the scanner, you move the scanner 10 feet, and all of a sudden you're through bushes and you're through all
Right.
kinds of things that it can't find anything that was similar to what was in the previous position. So targets are very helpful there too.
So now, just to give a comparison and you're talking about error. So the error of the iPhone, obviously, as you said, using it for accident reconstruction probably would work, right? When we start
Yeah.
measuring millimeters of blood stain and shooting reconstruction, that's not going to be helpful yet. So what error rate are we dealing with? I'll just call it the pro models, right? I mean, so if you're dealing with your terrestrial scanners, what's that versus like a drone on photogrammetry?
So when we're talking about something like a Leica or a Faro scanner, or ZNF scanner, like those, professional,
Right.
high grade equipment, and you're down to an accuracy level in and around 1 to 2 millimeters or so, something around that area. And obviously it depends on the type of instrument, but like the Faro S350 model that I use is down at about, they say 1 millimeter. I usually say 1 to 2 millimeters. It's around that ballpark. That's certainly sufficient for, bloodstain pattern analysis, and for the
The
like
shooting reconstruction.
yeah, bullet
Right.
trajectories and things like that. And that, yeah, when you're talking about a drone, a lot depends on, how high you're flying, the resolution of your camera, But let's say, if you're flying something let's say you're at 120 feet off the ground, and you want to map out an area that's 400 feet or 500 feet. It's a roadway or something like that. A lot of people overstate their accuracy claims with photogrammetry. So if you're using control points, okay, so GPS and high accuracy control points, you can get down to about a centimeter or two. Okay, somewhere in the ballpark. If you're not using any control and you're just flying, you will have, look at it this way, 90% of your points are going to fall about under 5 centimeters if you do it properly. Okay, under 5 centimeters is like 2.5 inches or so, a couple of inches, let's say. So, and it also depends where and what you're measuring. So if you think about, a vehicle crash or something that's spread out over, 100 meters, especially when it's a high speed crash,
Right.
a couple of inches is not going to make any difference at all to your calculations. So not a big deal. But when you're doing the more sensitive stuff, like for example, a suspect height analysis, so you're taking CCTV images and you want to couple it, you want to minimize your error as much as possible. When you're doing the trajectories and then the bloodstain pattern analysis, you definitely also want to minimize your error. So in that case, I typically don't rely on photogrammetry. I usually go with the laser scanner. It's probably the better instrument in those types of cases.
I mean, certainly we've seen in officer-involved shootings, and it's most common one that I guess we would probably have questions of, and trying to reconstruct with video the distance, between the suspect, between the officer, because obviously the question always comes up: was there another option, right? How
Right.
far away were they? And dealing with, and I've seen, matter of fact, I think they had a reconstruction at Acer where they were showing the difference between sound traveling the bullet and trying to use
Right.
video to put all those things together. So again, I think these are more tools to use, but as you said, sometimes it being off by too much changes the story in a direction that obviously doesn't answer the question we're going for, right? And
Yeah,
that's
exactly.
to find
Yeah.
out, was there another option?
Yeah, exactly. And like I always say, I always try to understand the error, because a lot of times, again, like sometimes, if you're just doing a crime scene drawing and you want to give people an idea of the space or something
Sure,
like
right.
that.
Where things were as we talked
Yeah,
about this.
exactly. So you're off by an inch or two. Like, it's not important. It's not going to make or break the case or anything. So in those situations, it's okay to, maybe photogrammetry or use a different type of technology, maybe your phone or whatever it might be. But, when you really have to get down to it, having a good handle on the error and what kind of errors you can expect is super important to put it into context. So if you've got a suspect, and one guy is he's 6'5". The guy, they think the guy is 6'5" in the video, but then the suspect you got is 5'8", right? There's a huge disparity between
Right.
there. So if it's plus or minus an inch on your calculation, you can definitely exclude somebody there. But now what happens is, if one person is 5'10" and one person is 6'1", and you've got 4 inches of error plus or minus during well, they overlap now, so you can't say as much about it. So understanding the error and the range of error is super important in these types of cases.
So, as we wrap up, one thing I'd really like to do, I know we've talked about a lot of different software that you're using and such, and if you don't mind sharing some of those links to different ways that people can get to them and stuff, we'll post that on the website. We'll post that with the video and such. So you're obviously working on the ejected cartridge casing. So what's another project that we see coming that's I guess of interest that you're starting or working on?
Probably the biggest one for me last year was the cast-off pattern analysis. So um, I was I looked at cast-off patterns, and there wasn't a lot of work in that particular area. So everybody knows, like, or a lot of people know in this area, like in impact pattern, and then you do an area of origin analysis to determine more or less where the impact came from. But then I started thinking about cast-off patterns, and if you have this sort of linear series of bloodstains that are projected on a wall or something, or a floor or ceiling, what can you say about it? And it's kind of intuitive. You see this kind of line that goes down the wall.
Right.
And you're like, well, it kind of came from here, right? So I found that a lot of people weren't doing anything with the data. They were taking photos and said, well, it's cast-off pattern, and that was it. So I was more interested in actually doing something with the data. And so I was using Ferrozone 3D software that has area of origin built in, and I kind of repurposed it. So I said, well, let me do that on a cast-off pattern and see what I can find. So I did a bunch of trials where I was in the Netherlands. So there was a company in the Netherlands that was helping me. And so we put like these motion trackers on people's bodies, and then on a dowel rod that was dipped in blood. And then we'd swing it at a wall, and it was, just your hand, and it was very natural. It was a human created motion path. And in fact, that's what we're doing now. So I published a paper last year that says, I call it the path volume envelope. And what it is a way of doing an analysis on a cast-off pattern. And I'm using a laser scanner and software and everything. And it gives you a box, let's call it. And inside of this box is the motion path of the object. So if I have blood on the end of a rod and I swing it, I've got this box now that kind of encloses. Somewhere in that box is the path of motion that caused these bloodstains to be projected on a wall or surface, whatever it might be. So that's the exciting one for me. I was really excited about it. I thought it was kind of cool because there was no other analysis like that, and so
No, it
really
is.
exciting.
It answers a lot of questions on investigation, trying to determine, because obviously we're trying to reconstruct, again, what happened and where people were, what they were doing, and it all plays a huge factor when we try to reconstruct these things. Obviously for the investigators, also for the detectives, and certainly by the time we get to court, right?
Yeah,
So,
for sure. Yeah. So hopefully it works out. We're doing some more work in that area, and I hope to keep going.
yeah, we can't wait to see what you have. So, as we wrap up, Eugene, thank you so much just for your knowledge, experience, and bringing this stuff to light. And we can't wait to see what you do, and certainly want to come back and see some of your future work as you do it. For listeners out there, if there's a topic you'd like to hear about, if there's a question you have for us, if you would like to sponsor the show, or if you know a topic or someone would like to be on the show, contact me, Dan, at crimescenetoday.com, and we look forward to seeing you next week. Take care.
Thanks, Dan. Appreciate it.